Hello, welcome to my channel. We will be doing question number 4, chapter 16. So it is quite similar to previous question we have done. Uh, just one in the last second. There is some trick in over here. I will tell you what. Okay, so we are given that speed or the velocity of an object is given by 9t square minus 63t plus 90. Okay, so many meter per second. Okay. Uh, and we understand from this statement that a particle p is projected from the origin so that it's moved in a straight line at time t second after projection. It means it passes the origin 0 at t equal to 0. So I mean at t is equal to 0, the distance was 0. Okay, anyway, so we will use this information. Now the first part says show that p first comes to instantaneous rest when t is 0. Okay, so instantaneous rest means the speed is 0. Speed is 0 when the speed is 0. So when speed is 0, this whole thing means 9t squared minus 63t plus 90 will be 0, right? Okay, if I divide everything by 9, I will get t squared minus 7t plus 10 equal to 0. Okay, this can be factored as t minus 2 into t minus 5. Okay, yes, 7 and 10, yes, equal to 0. So this gives you t equal to 2 and 5 seconds. So it means at these instances, meaning 2 second and 5 second, the object, the particle, it was at rest again. Okay. Now, second question. Uh, so the first answer, yes, show that P first comes to instantaneous when t is equal to 0. So first it comes to rest at 2 seconds, then again it will come to rest at 5 seconds. Okay. Now, second question part, find the acceleration of P when t is 3.5 seconds. Okay. Remember, acceleration is the derivative of speed, right? The derivative, I sometimes we write it as dot. Okay, so from here I can learn that acceleration is going to be the, when I differentiate this acceleration, it will become 2 9 the 18t and minus 63. Okay, and now we need to find the acceleration when t is 3.5. So what I will do, 18 times 3.5 minus 63, and it will give me the answer to be 0. Okay, so 3.5 second acceleration was 0. Okay, very good. Now the third question is find an expression for the displacement of p at time t. Okay, so the displacement is the integral of speed, right? We have talked about before this thing as well. Integral of the velocity, sorry. Okay. Uh, okay, so this displacement as a function of time, this is going to be integral of the velocity, right? Okay, so when I want to integrate this velocity expression, it will give me 9 and t cubed by 3, makes sense, minus 63 and t squared by 2 and plus 90t and plus a constant of integration. Okay, so this can further be written as 3t cubed minus 31.5 t squared plus 90t plus c. Okay, and again, we know that the object was at origin at time 0. So when t is 0, s was 0. So from here, so this displacement is 0 when t is 0. So 0 minus 0 plus 0 plus c. So it means c is 0 as well. Okay, so from here we learned that C is 0. So my final expression for the displacement, it is going to be 3t cube minus 31.5 t squared and plus 90t. That's it, there's no C. Okay, now, okay, so this is third part. Now, fourth part is a bit challenging. Find the distance traveled by P. Okay, now that's the distance difference between distance and displacement. Okay, so let me give you the bigger picture what's happening right now. Okay, this is T. So if I try to plot acceleration, acceleration is given by 18t minus 63. So it's a straight line, something like this. Okay, so this is the expression for the acceleration. At time 0, the acceleration was minus 63. You can see from the expression. And when time was 3.5 second, so at 3.5 second, acceleration was 0. We found it over here. Remember, when time is 3.5 second, acceleration was 0. Okay, now if I want to plot the velocity, let me use some other color. Come on. Yes. Okay, so let me plot this velocity. Velocity was 0 at 2 and 5. So this is 3.5. I'm just making a rough sketch, and this is 5. So it is something like this. It goes, you see, it's a parabola, and t squared is positive. So it means it's a parabola opening up. So it is something like this. It starts from here, it goes to 0, and again it started like this. So this is the curve for the velocity. Okay, so at time 0 we can see that velocity was 90. Okay, and at time 2 the velocity was 0, and at time 5 it was 0, and the acceleration, I mean the change in the velocity was 0 at 3.5. So this is the stationary point of the velocity curve. Anyway, so in the first 2 seconds, the velocity was positive. Okay, so it means the distance and displacement is the same. Okay, so what's happening? This is the distance. Okay, yeah, this is the distance. Let me call it. So this is my origin point O. So it's the object starts from here. It keeps moving in this direction until 2 seconds. Right? At 2 seconds, the speed becomes 0. And then it comes back. It starts coming back. It's difficult to plot. And it starts coming where the speed was 0, so it's coming opposite direction. Okay. And then sometimes this acceleration becomes 0 again. And then it's again, speed become positive. Okay. And oh my goodness, what is this? Sorry. I didn't mean to want this ellipse. So let me delete this one. Okay, anyway, so I'm trying to tell you that in the first 2 seconds, the distance and displacement are the same. So no worry, I will use this expression. So the distance or displacement, it is same at 2 seconds. So I will use this expression 3 into 2 power 3 minus 31.5 into 2 square plus 90 into 2. So if you figure this out, this whole thing, 3 into 8, yes, this comes out to be 78, right? Okay, now the last part, this is A, and now I want to do B. B is tricky, okay, it's challenging. We have to find in the first 3 seconds. So in first 2 seconds, it's okay, but if I use the same expression, okay, uh, because I will get a wrong answer. What's happening that after 2 seconds, the it is moving in the opposite direction. Remember, I told you that first 2 seconds it keeps going up till here, and after that it comes back, right? So now the distance and displacement are different. Okay, if I use this expression, and find the displacement, it will give me the, let's say this is 3.5, so 3 is somewhere here. So it will give me the net displacement, mean this minus this. Whereas the answer is this distance displacement or this area plus this area. Okay, so if I want to find the distance at 3, what I will do, I will find the distance at 2, right? Plus distance from 2 to 3. And how can I find the distance from 2 to 3? I need to integrate 2 to 3, the negative of this speed. Okay, so what I will do, the negative of 9t square minus 63t and plus 9t. Okay, dt. I'm not sure if I'm able to convince you or not that why from 2 to 3 I have to do the negative of it. Uh, because but from 2 to 3 it is going in the opposite direction, right? So displacement is becoming less and less. I'm subtracting this area from this area. This is negative area. So the distance is keep increasing, right? So in order to find the distance, I need to add these two areas, not we need to find the distance, difference of these two. Okay, so this is going to be the distance I took was 78. We already found that, right? And in order to, if I can integrate this thing, uh, and the easiest way, you can do the integration directly as well, but the easiest way is that I will evaluate the positive of this expression. Okay, let me do it in the integration now. That is going to be complex. Okay, so yes, plus now the integral of this thing is going to be negative 3t cube and plus 31.5t square and minus 90t, right? And it has limits from 2 to 3. Okay, so this is going to be 78 plus. Now when I put the upper limit, I will have minus 3 into 27 plus 31.5 into 9 and minus 90 into 3. This is the upper limit, and when I put the lower limit, it will become minus 3 into 8 plus 31.5 into 4 minus 90 into 2. Okay, I hope you are following me. This is a bit complicated, so I'm not sure if I lost you. Okay, this whole thing, it comes out to be minus 67.5. And this whole thing will come out to be, we did the same thing before, right? This is, yeah. So it will give you minus 78, it will become plus 78. Okay. And when I simplify this with 78 plus 10.5, which is going to be 88.5. Okay, and this is meters. Okay, I hope I was able to explain it. It's a bit uh, complicated to understand. Thank you very much for watching. See you in the next video.